Hello and welcome. In this video we are taking a look at paper 3 of the Edexcel Foundation Maths GCSE paper series from November 2019. I hope you find this useful. If you do, please do subscribe to my channel and take a look at some of my other videos. Let's start with question 1 then. Write down two factors of 12. Well, a factor is any number that will divide exactly into 12. And these are commonly found in pairs, so if you can find two numbers that multiply together to make 12, you have your answer. So for instance, 2 times 6 make 12, that's one pair of factors. 1 times 12 makes 12, and 3 times 4 makes 12, so any two of these numbers. Question 2 asks us to find 1/3 of 30. Well, to find any fraction of any amount, we would first divide by the bottom number and then multiply by the top. So our first step is 30 divided by 3. That gives us 10. In this particular case, the top is number 1, so multiplying by 1 leaves the answer the same, 10. Question 3. Write 0.7 as a fraction. Well, let's just write this a little bit larger, 0.7. The trick here is to decide which column the last digit is in. Well, in this case, the decimal finishes in the first decimal place, and this column is the tenths. Therefore, this is actually telling us that there are 7/10, and that is the fraction 7/10. Question 4. Here is a list of numbers. Write down the number from the list that is a multiple of 6. So we need to find the number that divides exactly by 6. If you know your times tables, you will probably spot this one straight away. Otherwise, you could simply list the multiples of 6. So in other words, the 6 times table. 6 plus 6 is 12, plus 6 is 18, and straight away we have a multiple of 6, so 18 is your answer. Question 5. Change 4 kilometers into meters. Well, we need to know the conversion rate for this, so 1 kilometer equals 1,000 meters. Therefore, 4 kilometers equals 4,000 meters. Question 6 is giving us a grid of squares. We are asked to write down the ratio of the number of shaded squares to the number of unshaded squares. Therefore, we count both. Shaded squares, there are 3. With a ratio, we write down the 2 dots. Unshaded squares, there are 1, 2, 3, 4, 5. Therefore, the ratio is 3 to 5. It cannot be simplified, so that's our final answer. Question 7 involves a little bit of algebraic substitution. We are given an equation which says W equals 4U plus 3. And we're asked to find the value of W when U equals 8. So we need to substitute the 8 for the U. So we can rewrite this and it becomes W equals 4 times 8. 4 times U becomes 4 times 8 plus 3, and being sure to use BIDMAS, we do the multiplication first, so 4 times 8 is 32 plus 3, so W equals 35. In question 8 we are given a sequence and we are asked to write down the next two terms of the sequence. So we need to establish a pattern here. Well, first of all, let's look at the relationship between the first two numbers. From 1 to 3, that has gone up by 2. The next two numbers is 3 to 6, that has gone up by 3. From 6 to 10 has gone up by 4, and 10 to 15 has gone up by 5. So looking for a pattern, the gap between each term is increasing by 1 for each step that we make. So plus 2 plus 3 plus 4 plus 5. Therefore, the next step is going to be plus 6. 15 plus 6 is 21. and the next step will then be plus 7. 21 plus 7 is 28. So 21 and 28 are the next two terms. Question 9 is in two parts. So part A, Mrs. Brown asked each child in her class which pet they liked best, and she has a set of results here. We're asked to complete the frequency table. So looking at the two columns that are empty, we first have to count up the results in tally and then put the frequency on the end. To count the tally, you can do this a couple of different ways. You could simply first find all the dogs, or you could simply work through the list one at a time. So the first item will be a dog. The tally starts with a 1. Then we have a cat, and we are going to complete the tally one mark at a time. There is a rabbit. Then we have 2 dogs. 1, 2. Then a cat, a rabbit, and a cat. So a cat, a rabbit, and a cat. And I'm simply going to work through these: dog, hamster, dog. So now dog, we put the 5-bar gate. Then we have a hamster and another dog. Dog, cat, rabbit. So dog, cat, rabbit, and finally hamster, cat, dog. So hamster, that is the 5th cat, and another dog. So we've used tally correctly. Each time we get to 5, we've put the diagonal line down to show the group. That is now a tally chart. We're asked now to put in the frequency, and that is simply the total. So dogs, 5, 6, 7. There are 8 of them. Rabbits, 3. Cats, 5. And hamsters, 2. And that completes your frequency table. Part B asks us to use the grid below to draw a bar chart using this information we've collected. Okay, we need to make sure we put as much detail as possible on here. 3 marks available, so we don't want to lose any. I'm going to have difficulty being neat and tidy here, but along the bottom we need the names of the pets. So we've got dogs, we have rabbits, we have cats, and we have hamsters. And also along the bottom needs a label which says pets. Up the side needs to be the scale, starting from 0 going up in even units, and using the information we have here we need it to go up to 8. So 1, 2, 3, 4, 5, 6, 7, 8, and another label, number of pets. I would also put in a title, call it something very simple like favourite pets. We then now need to put in the columns, and for that you'd use a ruler. Keep it as tidy as possible. The columns need to be all the same width and also have the same gap between them. So we have dogs, looking at the information above, we have 8 of them. We have rabbits. Rabbits, there were 3. Cats, the amount was 5. And hamsters was 2. Your bar chart should therefore look something like that. And in fact, there is a part C to this question. It simply said, write down the most popular pet. Well, the answer is dog with 8. That is the tallest column. Question 10 has 2 parts, and we have 2 circles. In part A, we're asked to draw the diameter of a circle. So quite simply, with a ruler, a diameter is a line that goes from one side of the circle to another and goes exactly through the centre. Part B, we're asked to draw a segment. A segment is an area of a circle which is separated from the rest by a straight line. Again, it goes to 2 parts of the circumference, and we are asked to shade in the segment. Well, this segment can be shaded, and you can probably do this slightly easier than I can, but it is the area here. Question 11 is also in 2 parts. Let's look at 11A first. Dylan buys 13 bicycle lights for £7.50 each. He pays with 5 £20 notes, and we need to know how much change he should get. So the first thing we are going to calculate is 13 times £7.50, and the total of that is £97.50. £20 notes times 5 means he is paying with £100, so the next part is the 100 minus the cost of £97.50, and the answer is £2.50. And part B is about a bicycle. It's telling us that the normal price of a bicycle is £120, but in a sale there is 1/5 off the normal price. So let's find out what 1/5 is first. That's 120 divided by 5, and that gives us 24. So 24 is the amount that's been taken off, whereas to work out the price of the bicycle in the sale, it was 120. We need to take off the 24. The answer therefore would be £96. Question 12. Cornflakes are sold in 2 sizes of box. Here we have a table telling us that a small box weighs 450 grams and a large box 750 grams. Ray buys 3 boxes of cornflakes and some large boxes of cornflakes. In total she buys 5,850 grams, and we need to work out the number of large boxes that she buys. Okay, what do we know? We know how many small boxes she's bought, which is 3. So the total weight of those 3 boxes would be 3 times 450 grams. Therefore, total weight 1,350 grams. Now we know that the total weight of cornflakes that she buys is 5,850. If we take away 1,350, that's the small boxes, we then have the weight of the total of the large boxes, which is 4,500 grams. So if the large boxes altogether weigh 4,500 grams, if we take that and we divide that by 750 grams, that will tell us how many large boxes Ray has bought, and the answer is 6 large boxes. Question 13 gives us a stem and leaf diagram, and it tells us it's the information about ages of people in a social club. We have a key to tell us how to read the stem and leaf. It tells us that 4/2 represents 42 years. In other words, the 4 and the 2 is someone aged 42. The good thing about stem and leaf is that their ages are already in order. So when we are asked to find the range, well, the range is the largest number take away the smallest. In this case, the oldest take away the youngest. So the oldest person is 74. 7/4 is 74. Take away the age of the youngest person, well, the youngest is 31. So we have 74 minus 31. The answer is 43. Question 14, here is a rectangle, and here it is, 7 centimetres by 3 centimetres. Corby has to find the perimeter of the rectangle. He writes perimeter equals 7 times 3. What mistake has Corby made? Well, in your own words, he has actually calculated the area, not the perimeter. So the perimeter would be 7 plus 3 plus 7 plus 3. Perimeter, you have to add the outsides up. We multiply for area. And here is part B of the same question. Here is a triangle. So we're given a triangle and we are given the lengths of the sides in terms of x. So we know the bottom measures x, then we have x plus 7, x plus 8. It says Iram solves a problem about the triangle to find the value of x, and her answer is x equals -2. We have to explain why her answer must be wrong. this question could be a little intimidating at first glance, but actually we don't know what problem she was solving. Maybe it was trying to find the area of the triangle or the perimeter of the triangle. We're not given that information, but in fact none of this matters, because if we look closely, we're saying that Iram thinks that x equals -2. Well, if we look at the bottom side of this triangle, the length of the base is x. It has to measure something. A length cannot possibly be a minus. So your explanation in your own words is x cannot be minus because the base of the triangle cannot be a minus measurement. There's no such thing. Question 15. A lot of information here. We are told there are 800 students at a school. Each student has either a school dinner or a packed lunch. Then we're given some percentages. 31% of students have packed lunch, 55% of the students are boys, 60% of the boys have school dinners. How many girls have packed lunches? And you must show all your working. A question like this, we can see that these students have been split into two categories. We have girls and boys, and we have school dinner or packed lunch. So an ideal way to answer this is with a two-way table or a possibility space. Let's draw one of those. Okay, now we have the categories. So boys and girls, school dinner, packed lunch, and we have the totals. Let's complete the table. So we know altogether there are 800 students at a school. So the total here is 800. The first piece of information after that is that 31% of the students have packed lunches. So we need to find 31% of 800. So that is 31 divided by 100 times 800. And that gives us 248. So total number of students with a packed lunch is 248. From that we can work out how many students have school dinners, because it has to add up to 800 in this column here. So that is going to be 800 minus 248, which equals 552. So 552 total school dinners. We now know that 55% of the students are boys, so we need to find 55% of 800. So again, 55 over 100 times 800, and the total there is 440. So boys 440 in total. That goes at the bottom of the boys column. Again, if we go 800 minus 440, that will tell us that the other 360 students are girls. 360, it adds to 800 again. 60% of the boys have school dinners, so we now need to find 60% of 440. So once again, 60 over 100 times 440. The answer is 264. So 264 of the boys have school dinners. From here we can go in a couple of different directions. Let's look at how many of the girls have school dinners. Well, if the total school dinners we've already worked out as 552, and we know that out of that 264 are the boys, then the rest must be the girls. So 552 minus 264 is 288. So 288 of the girls have school dinners. We're now in a position to answer the question. We need to know how many girls have packed lunches. Well, out of a total of 360 girls, we now know that 288 of them have school dinners, so the rest of them must have packed lunches. And 360 minus 288 is 72. You may find with a question like that there are different directions you could go in. You might have found out how many boys have packed lunch and then worked out the girls from there, but the answer would be the same. Question 16 is a probability question, and we have one of our favourite scenarios, numbers of coloured counters in a bag. In this particular case we have red, blue, green and yellow, and we are told the probability of pulling out a red counter is 0.4, yellow is 0.25. We are asked to complete the table, and the extra bit of information is that we have a ratio of 3 to 4 of the blue and green counters. Let's start from the beginning. We know that when we add up all the possible probabilities in a situation like this, they have to add up to 1 in total. You put your hand into the bag, you will pull out a counter. That is a definite probability. So out of the probability of 1, we have the reds at 0.4 and we have the yellows at 0.25. So if we add those together, we get 0.65. So that's the total probability of a red and a yellow. Bearing in mind the total probability is 1, if we then take the 0.65 away from 1, we end up with 0.35. So 0.35 is the total probability of getting a blue or a green. We now need to split that 0.35 between blue and green, and we are given a ratio. Blue to green is 3 to 4. To work this out, we take the total probability and we divide it by the number of parts in the ratio. 3 plus 4 means there are 7 parts. So our next calculation is 0.35 divided by 7. 0.05. So 1 part of the ratio is 0.05. We then need to put that back into the ratio. Blue has 3 parts, so that's 3 times 0.05, which equals 0.15. That is our blue answer. Green has 4 parts of the ratio, so that is 4 times 0.05, and that is 0.2. So 0.2 in the green box, and we have completed the table. Question 17 is part A and B, but we'll do both parts together here. In part A, we're asked to complete the table of values for y equals 4x minus 6. And here we have the table, and it is partly completed for us. Now let's take a practical look at this. This equation has no powers of x, only a simple x. Therefore, we know it's a linear equation. It's going to be a straight line. Therefore, the numbers in the bottom line for y here are going to follow a pattern. And a useful shortcut is to find the pattern. So rather than starting at -1 and being worried about multiplying minuses, let's look at the other end of the table here. We know the value of y when x is 4. Let's find the next box along. So we're going to substitute 3 for x. So we get y equals 4 times 3 minus 6. And using BIDMAS, 4 times 3 is 12. So that is 12 minus 6. So therefore y equals 6. So let's put 6 in the box here. Now we can see that moving down from 10 to 6, we have gone down 4. It is a safe bet to assume that that pattern is going to continue. But let's check it out. So if we are going to assume it is down at 4, that would mean that the next value here would be a 2. It then goes down 4 again to -2, so it looks good. Let's, however, try out x equals 2. So therefore it would be y equals 4 times 2 minus 6, which is 8 minus 6, which is indeed 2. So our pattern is working. We are going down 4 each time. So -2. So -2 minus another 4 is -6. And minus another 4 again is -10. So finding the pattern takes some of the hard work out of the calculations. For part B, we then need to draw the graph of the same equation for the values of x from -1 to 4. So we're now going to put these coordinates on the graph. And this is almost a second check to our calculations because this should be a straight line graph. So we have -1, -10. So -1, -10 is here. We then have 0, -6, and 1, -2, 2, 2, 3, 6, and 4, 10. And the check of all of this is to take a straight line, and if we can draw it through all our coordinates, then we can be pretty sure we have the right answers and the box is completed correctly. Question 18, another graph question. We have a triangle placed on a graph and we are asked to reflect shape P in the line y equals 3. So first of all we need to identify the line y equals 3, and in fact it is the line across the graph here where all the coordinates of y are 3. Once we've found that line, we are looking for a reflection, so almost as though we are looking in a mirror, and therefore we need to draw the triangle pointing in the opposite direction so that it is indeed a mirror reflection of triangle P. And just to be sure, if we measure the sides, this is 1, 2, 3, 1, 2, 3, 1 across the bottom, and it's pointing in the opposite direction, so we're all good. Question 19 simply says solve 4 brackets x minus 6 close brackets equals 44. There are a couple of ways that you might approach this depending on how you see the picture. Your first inclination might be to expand the brackets. Now if you did this, it would be 4 times x, so you would get 4x, and then it will be 4 times minus 6, so that's minus 24, equals 44. We will then move the minus 24 to the other side of the equation where it becomes a plus. So you end up with 4x equals 44 plus 24. Therefore 4x equals 68. Then if we move the 4 to the other side of the equation, it becomes a divide. We end up with x equals 68 divided by 4. X is therefore equal to 17. However, another way you might approach this is to first of all move the 4. Take the 4 to the other side of the equation. At the moment it is a multiply, it is being multiplied by the brackets, so it moves to the other side. You then have a divide, so you would end up on the left hand side with just x plus 6. No need to have any brackets anymore, it's not being multiplied by anything, equals 44 divided by 4. Therefore x minus 6 equals 11. If we then move the minus 6 to the other side, it becomes a plus 6, so we end up with x equals 11 plus 6, and once again that equals 17. Either method is good, take your pick, it all depends how you see the question yourself. Question 20, we have a Venn diagram and we're asked to complete it with the information that we have above here. So the universe, there's the universal symbol, in other words every number in the Venn diagram are the numbers from 1 to 13. In A, set A, we have multiples of 3, set B we have even numbers. So let's make this set A and this circle set B. We then have to put the numbers in the correct space depending on what they are. And I think because we have two different sets here, we need to investigate each of the numbers as we go along and put them in the correct place. So number 1, is it a multiple of 3? No, it isn't. Is it an even number? No, it isn't. So it doesn't belong in either circle, therefore it goes outside. 2, is it a multiple of 3? No, it isn't. Is it an even number? Yes, it is. therefore it belongs in set B. So number 2 will be in here. Number 3, is it a multiple of 3? Certainly, 1 times 3 is 3, therefore it belongs in set A. Is it an even number? No, it's an odd number. It just belongs in set A, so we're going to put it there. Number 4, multiple of 3? No. Even number? Yes, therefore it belongs in set B. Number 5, multiple of 3? No. Even number? No, it belongs on the outside. Number 6, is it a multiple of 3? Yes, it is. Is it an even number? Yes, it is. Therefore, this is the first number that belongs in both A and B. Therefore, it goes in the centre where A and B overlap. Number 7, not a multiple of 3, not an even number. It goes on the outside. 8 is an even number, but not a multiple of 3. So that belongs in set B. Number 9 is a multiple of 3, but not an even number. Set A. 10, not a multiple of 3, but it is an even number, so 10 goes in B. 11, no, it's not a multiple of 3, it's not an even number, it's another one for the outside. 12 is a multiple of 3, and it's an even number, so 12 is going to go in the centre here with 6. 13, multiple of 3, no. Even number, no. It goes on the outside. We've therefore completed the Venn diagram. Franco buys a house for £146,500 and he sells it for £158,220, and we have to work out the percentage of profit that Franco makes. A couple of ways around you could approach this. What I'm going to do first of all is I'm going to find out what the actual amount in cash profit that he makes. So I'm going to take the selling price and take away the price that he originally paid for it, and I find that he actually made £11,720 profit. We need to see this as a percentage, and the way to do that is to take the amount of profit, the difference between the two amounts, divide it by the original amount, which is 146,500, and then multiply that answer by 100. If we do the division, we get 0.08 times that by 100 is 8%. 22a, expand and simplify. Two sets of brackets. We have x plus 4 and x minus 9. So we need to multiply each term in the first bracket with each term in the second bracket, and to do this I am going to use the FOIL method to make sure I miss nothing out. So F stands for first, so the first terms in each bracket are the two x's, so I have x times x, x times x equals x squared. I then look at the outer two, the ones on the outer ends, which is the x and the minus 9, so x times minus 9 is minus 9x. I then look at the inner two. The inner two are the 5 and the x here, both positive, so I have x times 5 is plus 5x. And finally, the last two terms, which are the numbers, we have a plus 5 and a minus 9. So 9 times 5 is 45, a plus times a minus is a minus, so it's minus 45. The second stage is then to simplify, which we do by collecting like terms. So we have just the x squared to start with, but we have minus 9x plus 5x. Minus 9 plus 5 is minus 4x, and on the end minus 45. There we are, expanded and simplified. In part B, we're asked to factorise fully 9x squared plus 6x. So to factorise, we need to take out the highest common factor of each of the terms. We work from the numbers and then the letters. So first of all, the highest common factor of 6 and 9, of that would be 3. It divides into both 6 and 9. The highest common factor of x squared and x When we are looking at letters, we take out the letter with the lowest power, therefore it is just x. Now we open our brackets. We need to ask ourselves, what do I need to multiply this term by to go back to what it was? So what do I need to multiply the 3 by to get back to 9? I would multiply it by 3. How do I get from x to x squared? I multiply it by x. Then we have the plus. How do I get from 3 back to 6? I multiply it by 2. I already have an x. I don't need to multiply it by anything. It's already here. Therefore, I'm finished. So I have 3x, open brackets, 3x plus 2. If you're not sure of your answer, you can always re-multiply the bracket back out again to see where you end. In other words, 3 times 3 is 9. X times x is x squared, plus 3 times 2 is 6. X. There, we are back where we started. Therefore, our answer is correct. Question 23a. Use your calculator to work out. Then we have 29 squared minus 44.6 over the square root of 35 minus 1.9 to the power 3. Okay, this is all about using your calculator correctly. So we have part of the calculation over the line and part under. To set it up, there will be a symbol on one of the buttons of your calculators. On the version I'm using, it looks a little bit like this, which is the setup button for a fraction type calculator. Press that and then you simply put in the sum. So 29, you will then use the squared button and then you'll type minus 4.6. Then on the calculator, the big circular button with the arrows pointing left, right, up and down, if you hit the down arrow, it will then take you below the line. Now you'll notice that everything under the line here comes under the square root symbol. It's the square root of everything. So the first thing you're going to do is press the square root button and then type in everything that is under the line there, the 3.5 minus 1.9 cubed. A scientific calculator is set up to follow BIDMAS and it will therefore work it out in the right order. The answer you will see on your calculator screen will be 157.668,255, and that satisfies part A, writing down all the figures on your calculator display. Part B, write your answer to 4 significant figures. So 4 significant figures, well, we're looking at any figure after a 0. There are no zeros here. So the first significant figure is 1, then 5, then 7. That is 3 significant figures. We are writing to 4 significant figures. So the 4th significant figure is the 0.6. But don't forget, the number after that is a 6, so we apply the rules of rounding. It's 5 or above, so it will round the first 6 up to a 7. In question 24, we have a scatter graph showing information about the marks a group of students got in a science test and in a maths test. Looking at a scatter graph then, each of these X's is a student, and it shows the science test mark across the bottom and the maths test mark up the side. We are looking in a scatter graph for a pattern, and if you look at this particular graph, we can see there is a trend here where in general the higher a person scored on a science test, it would seem they also scored higher on a maths test. As these scores are increasing for science, they are also increasing for maths. We then know that Jamie got a mark of 34 in the science test. Therefore, his mark is going to be here. We need to estimate what we think he got in the maths test, and what we need to be doing is including him in this pattern here. The way we do that, and it is important that you draw this, we have what is called a line of best fit. So you take your ruler and you would draw a line where you think it fits the pattern best, where you are getting as close to as many of the X's as you can. Now it is only an estimate, therefore when you use your own line, you read up from 34 and where it meets the line here is going to be your estimate for his maths test. In my example here, it looks as though he scored about 39. Depending on exactly where you draw your ruler line, you may have a slightly different answer, but it is only an estimate. Question 25. The table gives information about the times taken in seconds by 18 students to run a race. We need to work out an estimate for the mean time and give our answer to 3 significant figures. Okay, let's have a look at this. We have some times here, but they are given as a range of times, so that we know that one student ran the race between 5 and 10 seconds, 2 students between 10 and 15 seconds. So what we need to do, because we do not know the time of every particular runner, is to use the midpoint, the average. We are working out an estimate here, so we use the center time. So we need a second column on this box, which we would call the midpoint. Now, the midpoint of 5 and 10 seconds is 7.5 seconds. Exactly in between 10 and 15 is 12.5 seconds. Between 15 and 20 is 17.5, and 20 to 25 is 22.5. We now know what the midpoint, what the average time for each of these groups of runners is. So if we multiply out the numbers of runners by the midpoint, by the average, we get an estimate of the total time taken. So one runner, 7.5, 1 times 7.5 equals 7.5. 2 times 12.5 equals 25, and so on down the table. We now have the total estimated time for each of the groups of runners. If we add these together, we get the estimated total time for all the runners, and they add up to 335 seconds. Now that we have the total time, if we divide that by the number of runners, in other words 335 divided by the 18 students, we get the answer on a calculator of 18.61111 continuous. So the answer says 3 significant figures. We are therefore looking at 3 numbers, 1, 8 and 6. Therefore the answer is 18.6 seconds. Just as an added note, had the next digit after the 6 been higher than 5, we would have rounded up to 18.7, but it's only a 1, so 18.6 is the correct answer. Question 26 asks us to write 37 centimeters cubed in millimeters cubed. Well, this can be very confusing, but we do know that 1 centimeter equals 10 millimeters. That, however, is for a straight line. If we are looking at area, 1 centimeter squared is actually 100 millimeters squared, and 1 centimeter cubed is in fact 1000 millimeters cubed. So this is what we are using here. 1 centimeter cubed is 1000 millimeter cubed, so it is 37 times 1000 equals 37,000 millimeters cubed. Question 27. Nima was driving to a hotel. He looked at his sat-nav at 1:30. He arrived at the hotel at 14:48. Work out the average speed of his car from 1:30 to 14:48. Well, we need the formula to work this out, and it is one of the triangles that we use to remember the formula, and it is distance, speed and time. So this tells us that speed equals distance divided by time. Well, we know the distance. The distance is the easy part. That is 65 miles. Now we need the time. Well, from 1:30, 13:30 to 14:48, well, 1:30 to 2:30 would be 60 minutes, and from 2:30, that's 14:30 up to 14:48 is another 18 minutes. So he's actually done 78 minutes. Now we want the speed in miles per hour, not miles per minute. So let's convert the 78 minutes into hours, and we do that by dividing it by 60, the answer to which is 1.3 hours. So going back to our calculation, speed is distance divided by time. Distance is 65, time is 1.3. 65 divided by 1.3 equals 50. So his average speed was 50 miles per hour. Question 28 is in 3 parts, so let's have a look at part A, and I'm just writing it larger to show you how this works. We are asked to write 32,460,000 in standard form. Well, standard form means that we are putting the decimal point after the first digit, so it's going to start at 3.246. We have to look now at how many powers of 10 we need to multiply this by to get back to the original number. Now we're putting the decimal point in between the 3 and the 2, bearing in mind it was originally at the end. So we are moving it 1, 2, 3, 4, 5, 6, 7 places. So that means we are multiplying it by 10 to the power 7. Part B asks us to write 4.96, I'll write it out again, times 10 to the minus 3. Now this time the minus 3 tells us that we are making the number smaller, therefore we are moving the decimal point in the opposite direction, so it has to go 3 places. So we are going to move it 1, 2, 3 places. In the spaces that we've created here we have to fill in with zeros, and the decimal point is going to be there. So the answer is 0.00496. Asma was then asked to compare the following 2 numbers. A is 6.212 times 10 to the 8 and B is 4.73 times 10 to the 9. Now she says that because 6.212 is bigger than 4.73, A is bigger than B. Is she correct, and what is our reason? Well, the answer is no, she's not correct, and the answer is because of the powers of 10. We are multiplying B by an additional power of 10. Therefore, even though 6.2 is currently bigger than 4.73, by multiplying this by an extra 10, B will be the larger number. That needs to be put in your own words here. Question 29. The diagram shows a regular pentagon and a parallelogram. Work out the size of the angle marked X. The way we're going to do this is we're going to find out what the angle inside the parallelogram is, and we're going to take that away from the whole corner of the pentagon. That will give us the remaining part of X. So let's have a look at the parallelogram first. Okay, there are a couple of different ways you could do this, but if we take this line down here and consider the 2 lines across, we actually have a pattern here which tells us that this angle and this angle are co-internal angles, one of the angle rules, and they add up to 180 degrees. Therefore 180 minus 117 means that the angle here, and I'm going to call it Y for a moment, must equal 63 degrees. So we know that Y equals 63 degrees. We now need the whole angle here. Let me change colour. We are now looking for the whole angle of the inside of a pentagon. Now for any multi-sided shape, to work out the internal angle, well, to work out the total of all the internal angles, we look at the number of sides. Pentagon has 5, take away 2, and then we multiply that by 180. Okay, so that is 3 times 180, and that is 540. So the total of all the 5 angles is 540. If we therefore divide that by 5, we get 108 degrees. So the whole angle at the corner is 108. If we take away the part that we know is 63, it means that x must be 45 degrees. And the last question, number 30. We are told that shape A is a quarter circle and it has a radius of 15 centimeters, and B is a circle. Area A is 9 times the area of area B. We need to show that the radius is 2.5 centimeters on B. The way we're going to do that is, first of all, let's find the area of A. Well, we know that the area of a circle is pi times r squared. Pi r squared. We know, therefore, that the area of a full circle with a radius of 15 would be pi times 15 squared. Therefore, we have area equals pi times 225, and using pi as 3.142 times 225, we get 706.95 centimeters squared. Now that's the area for the whole circle. We therefore need to divide that by 4, and if we do that, we get the answer of 176.7375 centimeters squared. Now that is the area of A. So we're now told that that is 9 times the area of B. So we need to take our 176.7375 and we need to divide that by 9. If we do that, the answer we get is 19.6375 centimeters squared. That is the area of B. We need to do things in reverse now, going back to the same formula. Area equals pi times r squared. Now we know the area and we know pi, so by rearranging the formula we get area divided by pi equals the radius squared. So we have 19.6375 divided by 3.142, that is pi, and we get the answer 6.25. That is the radius squared. So to find the radius we need the square root of 6.25, and that is 2.5 centimeters, which is what we were asked for. And that completes the November Paper 3 2019 Foundation Maths paper. I hope you found that useful. If you have, please do hit the subscribe button on the screen now, and hopefully I will see you again in one of my other videos. Thank you very much.